So this video we're looking at Rolle's theorem. The extreme value theorem states that a continuous function on a closed interval must have both a minimum and a maximum on that interval. All right, now both of these interval or values can occur at the endpoints. So Rolle's theorem is going to give conditions that guarantee the existence of an extreme value on the interior of a closed interval. Okay. Now, what theorem 3.3 or Rolle's theorem says is that if we let f be continuous on the closed interval from a to b and differentiable on the open interval from a to b. So once again, it's got to be continuous and it's got to be differentiable. If f of a equals f of b, so if the y value associated with both the endpoints are equal, then there has to be at least one number in that interval that the derivative is equal to 0. So if this, let me get my pen. There we go. If we have an endpoint and an endpoint, then at some point, if it moves from here to here, there has to be some maximum or minimum, right, where I have a horizontal tangent equal to 0. There doesn't have to be both. It could just be that it goes up like this and I have 1. It could go down like this and I have 1. It could go like this and I have 1, 2, 3, 4, 5, 6, 7, 8, right? All I know for sure is that if the endpoints have the same y value, there has to be at least one point in there of horizontal tangency. Here's a good picture, not my crazy drawn one, that shows this exact thing, right? If I plug in a and I get the same value for a and b, then there has to be somewhere in here where we have a horizontal tangent or the derivative equal to 0. So somewhere where f prime of c equals 0. Now, if we drop the differentiability requirement, f is still having a critical number at that point, but it may not yield a horizontal tangent. Okay, so notice here we have a relative maximum, but we don't necessarily have a horizontal tangent line. Now we can use Rolle's theorem to find the two, well, we're not going to use Rolle's theorem to find the intercepts. We're going to use Rolle's theorem once we have determined the two intercepts. We're going to show that there is some point between those two intercepts that has a maximum or a minimum. So why is that the case? Because what is the y value at the x-intercepts? Well, I know that just means x squared minus 3x plus 2 equals 0, right? My y value for both of these values will be x equals or y equals 0. So I know I can factor this plus 3 minus 2 minus 1. That gives me that x equals 2 and x equals 1. That means somewhere between 1 and 2, there has to be the first derivative equal to 0. Can we prove that? Well, I believe we can. So let's look at it. So we've already done that. We get x equals 1, x equals 2. All right, so we know that f of 1 and f of 2 both give us 0. That's the y value. We just proved it. Those are y-intercepts. So if x equals 1, y equals 0. If x equals 2, y equals 0. So we know that somewhere in this interval between 1 and 2, there is a first derivative equal to 0. So how do we do it? We find it by differentiating f, right? So when we differentiate our function, which was what? X squared minus 3x plus 2. If we differentiate that, we get 2x minus 3. We set that equal to 0, move the 3 over, divide by 2, we get x equals 3 halves. Is 3 halves between 1 and 2? Absolutely. Directly between, as a matter of fact. And here we can see exactly what it looks like. Now, we didn't do anything in terms of using Rolle's theorem to actually find a point. That's not the point. Rolle's theorem is a strictly mathematical theorem that proves that if we have 2 points that are equal, the y values are equal for those x values, then there has to be a maximum or minimum somewhere in there. Doesn't pop up a lot, but it does pop up enough that it's a really important theorem to know. So if you have any questions about Rolle's theorem, please just shoot me a reminder or ask questions in class.